Good. Yeah, thanks for the introduction, Matt. So I'm here to talk about a little bit the European side of things. So new horizons for European open source robotics is the title of the presentation, but I just want to show you a little bit what has been going on in Europe and what is going to happen in the future. First of all, I just wanted to shortly introduce to you also Fraunhofer IPA as an organization. So for those of you who do not know Fraunhofer Society, it's the largest applied research organization in Europe. It's non-profit. We have about 80 research institutes, more than 28,000 employees, and an annual research budget of around 2.8 billion euros. Fraunhofer IPA, the institute that I'm employed at, is focusing on manufacturing engineering and automation. And we have around about 70 million euros of annual research budget. We are located in Stuttgart, Germany. You will probably know a number of companies coming from there, like Bosch, Daimler, Mercedes-Benz, Porsche, and all these companies are located there. So you could call it more or less the Silicon Valley of mechatronics in Germany. What do we have at our institute? So as I said, we focus on manufacturing engineering, and we have the whole palette from, let's say, Industry 4.0 research centers over biomanufacturing laboratories to, let's say, the robotics experimentation area and many more. So we can actually cover most of the production processes and manufacturing process that you encounter in industry. We've been long-term ROS user at Fraunhofer IPA, so we adopted it quite early at the end of the 2000s. Yeah, and essentially we started with using ROS with the service robotics platform, our CareRobot, I'll show you later. We've been piloting the ROS Industrial concept with Southwest Research Institute since 2012. You can see here on the right, the first conference that we held here at Fraunhofer IPA. And since 2014, we are managing the ROS Industrial Consortium Europe. You can see here, we also, let's say, the evolution of, for example, our service robot, the CareRobot. And since 2008, or 9, we started getting into also using ROS for the service robot, and that also led to us using it with industrial robots. We've been doing quite well with also creating some startups based on ROS. So in 2017, we had the spin-off, which is called Motion Robotics, which today sells the CareRobot platform for service robotics for healthcare use, but today also more and more in let's say, shopping or shop floor applications in manufacturing. We have the company DragonBot that builds upon the ROS Industrial stack and provides easy robot programming solutions. And just this year, we also founded the spin-off Node Robotics, which creates interoperable navigation solutions for different kind of robots. Here you can see the smart transport robot of BMW, which is running the software of the startup. Yeah, recent achievements in Europe, maybe you know or have heard, we've had quite some funding from the European Union to boost, let's say, ROS usage in Europe. This funding is slowly fading out now, and we're looking, let's say, towards new horizons. And there I can present to you our new scheme there, which is the KI Fortschrittszentrum, which means AI Innovation Center for Cognitive Robotics. So let's start a little bit and look into ROSin. What have we achieved and done in the last few years? So on the one side, here you see the main pillars that the project had. So here we focused on better software quality in ROS to make it more business friendly, to create more components and to make it more accessible. I just want to show you some of the recent results that had quite some impact. On the one side, you certainly know the UR driver that has been developed in this project. So there we are, this was actually done in a collaboration between Universal Robot and FZI, both are partner companies in the ROS Industrial Consortium in Europe. This is actually the first UR driver that really has OEM support. And so quite some nice features actually that you can integrate ROS into UR caps with this driver. Later on, I will also show you one application that we have developed here at Fraunhofer IPA that uses this driver for welding. Finally, you can also use the driver for simple external control as you're used to. And there are many more features in this driver. It has also had quite some impact on GitHub. You can see there's quite some contributors. And currently, there's also an effort ongoing to bring this driver to ROS2. And there is already a beta version out there for testing. So that's really cool. Another achievement within the ROSin project that we had in the recent years was this motion planner from Pilz company, which focused on creating motion planners for industrial use, so deterministic motion planners. Before that, there were only let's say non-probabilistic motion planners in, for example, MoveIt. But today, with the motion planner created from Pilz company, you also have the probability or the possibility to use industrial accuracy and deterministic performance to create your path using the standard commands that people are used to in industry, like lin, point-to-point, and circ. So also pretty nice, and this has now also been merged into the MoveIt motion planner tool. The next thing I wanted to shortly present to you is also the project the FTP project that was led by Robotics. It's a Swiss company that develops the Wii Bot Simulation. So there we were also able to fund all the interfaces needed and integration into ROS2. And the great thing about it is that it's now also part of the ROS core packages. From, let's say, European point of view, that is quite an achievement because now we actually have 2 simulators in the core packages of ROS2, one from the US and one from Europe, which is, let's say, good for our funding agencies here. If you want to know more about the results, so these were only 3 small results that I wanted to bring up here. You can also check out the website of the ROSin project. They are all listed there. Probably something interesting for you there. So there's a lot of things to see there. So then let's go into, let's say, the new horizons. So more on the side, ROS Industrial and integration into the AI Innovation Center. So the story about this is that we actually want to create this kind of a ROS Industrial Lighthouse in Baden-Württemberg. So that's the region around Stuttgart in Germany. For this, actually, we received some pre-funding from the region here, from the government in the region of 2 million euros in 2019. And this was actually used to build up the AI Innovation Center. Since then, we've had more than 41 transfer projects around ROS, AI, and other software-related topics for manufacturing. With all the companies that we have here, you probably, well, I already told you about some of them, you know, SICK, Pilz, Siemens, and all the others. So there's a lot of these manufacturing companies based here. And well, that kind of led to the development that we have now. So we just closed a deal with the government as well as Fraunhofer Central on another startup funding on for this AI research center. So we are now going to receive over the next 4 years for this budget of 23 million euros, of which approximately 10 million euros are going to be invested into new and improved ROS-based technologies. And we are foreseeing that around 30% of the developments are going to be published as open source. So that's said to that, I think that is quite great news here. We also have some let's say research roadmap already scheduled for that. One thing that we mainly want to tackle is the lack of model-driven engineering in ROS. So that stems from the problem that in general in ROS, you really do not have some integrated development solution available. So you always need to create it on your own. That sometimes is really hard to for companies that start with the development of ROS, for developers that are used to maybe Windows development and just using Visual Studio. We also found the problem that actually ROS-based robot systems can be quite complex in the end and therefore hard to understand. So if you have all your nodes and how they interact, so that is also one problem to make that a little bit more understandable. Another problem is that if you generally have model-driven solutions, that means that you typically need to start from scratch, model everything, and yeah, that cannot be, because one of the biggest advantages in ROS is actually using the ecosystem packages that are already available. Another thing that I said already in ROS, we do not really have this model-driven approach yet. So that's something that we want to change. So we also want to give the opportunity to just integrate code into this model-driven solution. And another problem that we have is that currently, if you do system integration with ROS, this mainly goes by trial and error. So you write your, for example, launch files, and you have no way of verifying it. This just works in the end with trial and error. Therefore, we have these solutions planned. So for the integrated development solution, we are currently working on a ROS development, graphical ROS development toolchain. I will show a picture later. We are looking also into graphical modeling of ROS systems already during design time, into model extraction, so that you can use ecosystem packages and extract models from them, so you can use it in the graphical modeling tool. And there we are also then looking into providing the capability of generating boilerplate code, so you can actually create a model in your model-driven toolchain and say, okay, here I want to create a model based on just handwritten code, and then it generates for you already the boilerplate code in ROS or ROS2. And finally, we also have this validation part. So essentially there we are currently working on generating launch files as well as URDFs from the model that we have. And in that way, you do not need to do that much validation on these parts of your ROS system. So there, actually, my colleague Nadia Garcia is working on that, and the lead on that activity. We already have a beta version out there. You see the source code, the repo below. So if you're interested, check it out. The whole thing, I just wanted to show also shortly the process of using it, more or less, works like this. So on the one side, you have the step one, where you have this tools for model extraction from the ecosystem. So you just indicate a package, and we have a tool that then extracts the models from you. These you can then integrate into this graphical ROS system design solution, which is currently based on Eclipse. Where you can then actually set up your ROS system. And finally, this can then be used to generate launch files, to generate Python boilerplate code, C++ boilerplate code, and also to generate the full ROS workspace structure that is necessary for deploying this system design that you have developed. Currently, this is, let's say, at an early beta stage. But with the funding that we acquired now, we are quite positive that we can actually push this forwards quite a lot. Another thing that is also related to this activity that I wanted to present is actually this model-based observer generation. So here we are focusing more on diagnosis and monitoring for running ROS systems. So on the one side there, we have the ROS graph observer that we're currently developing, which actually takes a ROS system model and checks during runtime whether this ROS system model is running or if there's a problem with running it. And additionally to that, we also have a property observer that can be used in the modeling solution to generate observers for properties of ROS nodes. So for specific topics, you can set some ranges that are then continuously monitored during operation. And you get error messages when these ranges are exceeded, and all this is generated automatically. Yeah, there the contact is actually my colleague Harsh. Yeah, he's also happy to provide to you some information there. Currently, the stage is it's being tested in ROS1, and ROS2 is under development. You can also already find the sources on GitHub, as you can see below, but it's work in progress again. So this is how this solution works. Essentially, you have to define a desired ROS system. So what kind of nodes you want to have running in your system. And then we have a tool that actually observes the running ROS system on your robot, which nodes are running and so on. And this is then fed into a model interpreter as well as a model comparison module. And when there is some kind of problem there, we also can publish and generate diagnostic messages. Similarly, for the property observer, this works like that you specify a specific topic that you want to observe and a specific function that you want to put on this topic. For example, here we tried it out with a battery monitor, and then we also generate these kind of diagnostic messages once the limits are exceeded. So here we are actually looking into, as you can see in this whole project, we are really looking into simplifying, the design process for ROS system, and also making the runtime more reliable in the end. We have a small roadmap currently that we are developing and extending for this effort. So this year we are going to focus mainly on this ROS2 model-driven development. So the solution that we have right now is mainly focusing still on ROS1, but we want to port everything to ROS2. And the first things that we want to actually publish and make use of, as you've heard, we have this model extractor, which we will also use this year already to generate automatically interface documentation. So I think that's going to be the first real use that we get out of it, and will actually be quite beneficial for the ROS community to have a repository where you can then just check for each of the nodes that are available in ROS what kind of interfaces this node has. Finally, we are also working on launch file generation for ROS2 and these runtime observers. In 2022, we are also going to focus a little bit more in terms of modeling onto hardware characteristics, generation of URDF files from the model, and deployment of other artifacts. So right now, I told you we can only generate workspaces, but there we want to go more into the generation of snaps and Docker files. And finally, we also want to focus on runtime reliability there. So this means deploying ROS nodes redundantly, and also generating the necessary glue code for redundantly deployed ROS nodes. So this, I think, to be said to, let's say, the more design purposes that we are currently looking into. Now, I just wanted to show you one example of application development, ROS application development that we have currently ongoing. I have a video here. I hope that I can shortly show it. So we have been working with this UR robot driver to develop this welding solution, which actually you can see here on the end effector. You see a camera, and you see the weld gun. So this 3D camera actually checks the workpiece that you have, and then quite simply by simply teaching this application that we have that actually extracts the weld seam that is necessary, as you can see here. So there's just 4 or 5 clicks that you have to do, and you create this this weld seam. And the nice part about it is, because you have the camera, actually you can also detect when the workpiece is moved. So if you have different kind of workpieces, or if you want to weld a number of workpieces after each other, you don't necessarily need to have some fixtures anymore. So that's, I think, quite nice. This is currently also in beta testing. So if you're interested in this solution, it currently runs on your caps, which is then integrated with the ROS system. You can also contact me or my colleague Johannes Stoll if you're interested in using and testing this solution. It's available as your cap. I also wanted to point out that we are doing ROS2 trainings currently virtually. The first one this year is already done. We had quite a nice training there with 13 participants. All our trainings are now completely on ROS2 and done remotely via AWS EC2 instances. So if you're interested, you can also just contact me. That's all from my side. If you have questions, you can just ask me. If not, I would say, Matt, sorry for the delay.
Okay. We're up against